Well, hello, Year 12. Welcome to your feedback session for the breadth paper. All the question of the breadth paper should be done relatively quickly. Let's try. So the first question, nice, about iron or its isotope. They give you the abundance of each isotope, so you had to use the relative isotopic mass of each isotope and their abundance to find the average or the relative atomic mass. So make sure you use your calculator correctly, and you have to multiply 54 by 78.54, etc., etc. Don't forget to divide by 100, and you should find 54.63. They ask you to give an answer to two decimal places. Make sure you give an answer to two decimal places. Um, and again, if your result is not between 54 and 58, something must have gone wrong. Okay, so be very critical of your answer. Next bit, iron can be extracted from iron ores containing the oxide Fe2O3. What is the systematic name for Fe2O3? So with a systematic name of an ionic compound with a transition metal, you have to give me the oxidation number of the metal. So in that case, we have overall no charge. Each oxygen is -2, so that's -6. So Fe2 must be responsible for +6. Therefore, each Fe must be 3 plus. Is therefore the iron 3 oxide. Balance the equation for the reduction of Fe2O3 with carbon monoxide. I forgot when I did it, so I have to think about it. So we already have 4 oxygen on the left, only 2 on the right. How is that going to work? I know I did it. I forgot how I did it. I did it wrong to start with, but then I fixed it. How did that work? Oh yes, we have, because we have 3 oxygen, we need a factor 6 to get it. So we need 3 CO, and that gives us 3 CO2, and then we balance the Fe at the end too. That wasn't the easiest one to balance, but trial and error, and you should find the correct answer. When you have this in a real exam, don't panic. Take your time, do it. Next one, that's good. The iron compound FeNO33, iron nitrate, decomposes when heated. The equation for the decomposition is shown below. We know the molar mass of FeNO33, even though we could calculate it ourselves. And we know that 4.836 grams of FeNO33 is heated until it was completely decomposed. Calculate the total volume of gas in dm cubed produced at RTP. So first, you're going to calculate the number of moles of iron nitrate you start with by doing the mass divided by the molar mass. Then you know that 4 iron nitrate makes 12 NO2 and 3 O2. That's the only thing we need to consider because we're looking for the volume of gas. So make sure you include the NO2 and the O2. So we did find 0.02 mole for iron nitrate. Then remember the easiest way to find out the number of mole produced. To do this equation, the number of mole of NO2 divided by its coefficient, 12, is the number of mole of iron nitrate divided by its coefficient, 4. So the number of mole of NO2 is 12 divided by 4 times 0.02, which is the initial number of mole of iron nitrate, and that is 0.06 moles. You're doing the same for oxygen. The number of mole of oxygen divided by its coefficient equals the number of mole of iron nitrate divided by its coefficient, 4. And so you have the number of mole of O2 at the end is 0.015 mole. The total number of mole of gas is the number of mole of NO2 plus the number of mole of O2, 0.075 moles. And we know that 1 mole of gas occupies 24 dm cubed. Therefore, the volume occupied by these gases is 1.8 dm cubed. What is the difference between a strong and a weak acid? You need to know that by now. You're going to review it in year 13, sorry, I might be lost there. So a strong acid fully dissociates in solution, a weak acid only partially dissociates in solution. This is all you need to say. Okay, then we have this huge thing. First question, we had to calculate the titer. So for the titer, you're going to do the final reading minus the initial reading for O, and make sure you use 2 decimal places, otherwise you will not get the mark. So relatively simple math. If you're not entirely sure, use your calculator, but you definitely should get this one correct by now. Then, calculate the mean titer to the nearest 0.05 centimeter cube that the student should use for analyzing these results. So remember, you're only going to take the concordant titer, the one in 0.1 on each other. So you have to consider number 2 and number 3, and therefore the mean titer is 24.20 centimeter cube. And then calculate the composition by mass of CH3COH in the descaler. Assume that CH3COH is the only acid in the descaler. So here we have this mean titer, and that is the solution of Na2CO3. Therefore, we can calculate the number of mole of Na2CO3. We have the volume, we have the concentration. Then we know from the equation that we have a 2-to-1 ratio, so we can also calculate the number of mole of CH3COH, and that would be in 25 centimeter cube. So here's the calculation. Number of mole of Na2O3 is concentration times volume, so 0.2 times 24.2 divided by 1,000, and that is 0.00484 mole. Then we know from the equation the number of mole of CH3COH is 2 times the number of mole of sodium carbonate, 0.00968 mole. And that is in 25 centimeter cube. So in 250 centimeter cube is going to be 10 times this value, so 0.0968. So we have the number of mole of ethanoic acid that was in the descaler. We have the mass, we have the molar mass and the number of mole. We can therefore calculate the mass of CH3COH, which is 5.808 gram, and then we know that to calculate the percentage in mass is going to be the mass of CH3COH divided by the total mass of the product times 100, which is 89.4%. This question is about covalent compounds of nitrogen. Ammonia NH3 is manufactured by reacting nitrogen and hydrogen gases. This is a reversible reaction, and the equilibrium is shown below. Two features of a dynamic equilibrium. So the forward and the backward reaction happen at the same rate. That's one feature. The second one is the concentration of reactant and product stay constant. And then you could also add that it happened in a closed system. I would always go for the first two and keep closed system as a backup plan. Next one. Okay, so we have this data. I have stated and explained the conditions of temperature and pressure that would produce a large equilibrium yield of NH3. So we can see from the data that the forward reaction is exothermic. It has a negative delta H. So if it's exothermic, decreasing the temperature is going to shift the equilibrium to the right to make more product, increasing the yield of NH3. Okay, you're going to compensate the change. So if you decrease the temperature, the system will shift to increase the temperature. Therefore, you're going to have more of the exothermic reaction happening. In terms of pressure, if you look on the left, we have 4 molecules of gas, or 4 particles of gas, only 2 on the right-hand side. So if you increase the pressure, you're going to favor the forward reaction, shifting the yield to the right-hand side, increasing the yield of NH3. And again, you need to say that there are less particles of gas on the right-hand side to get the formula. Next one, hydrazine, I don't know how to say it, N2H4, shown below, can be used as a rocket fuel. Fact. It would react with oxygen. To make this reaction, we have the enthalpy change of reaction, very exothermic, minus 581 kilojoules per mole. Calculate the average bond enthalpy of the NH bond. So remember, when you do that, you're going to have to draw all the bonds. A lot of you made a mistake because in N2 we have a triple bond NN. So you're going to have to use this value. So the energy gained to break the bond, you have to break 1 nitrogen-nitrogen bond, you have to break 4 nitrogen-hydrogen bond, and you have to break 1 oxygen-oxygen bond. So that is 158 plus 4 times this NH that we don't know, plus 498. The energy lost to form the bond, we have to form 1 triple bond nitrogen-nitrogen and 4 OH bond. And that's in total 2,801. So overall, the energy gained minus the energy lost equal the enthalpy change of reaction. So the energy gained is 656 plus 4 times the unknown NH on enthalpy, minus 2801 is minus 581. So if you make NH the subject of the equation, you will find plus 391 kilojoules per mole. Yeah. So take your time, make sure you have everything correct there. Here we go. Next one, hydrogen cyanide, HCN, is bonded by a single bond between the H and C atoms and a triple bond between the C and N atoms. Draw a dot and cross diagram for a molecule of HCN. Use different symbols for electrons from H, C, and N. Okay, so make sure you have your single bond CH, and make sure you have your triple bond CN, and you should look exactly like this. Next one, this question is about hydrocarbons. The skeletal formula and boiling point of 3 isomers of C6H14 are shown in the table below. State and explain the trend in the boiling point shown in the table. Refer to the isomer A, B, and C in your answer. Okay, so if you look at all of them, they all have the exact same molecular formula. They all have the exact same number of electrons. So we're going to have to look at the surface area of contact to explain the change in boiling point. And notice that A doesn't have any side chain, B has one side chain, and C has two side chains. It's more branched. So A is not branched at all, so I have a high surface area of contact between molecules, and it's higher surface area than B and C. B only has one chain, C has two, so B has a higher surface area of contact between molecules than C. The higher the surface area of contact, the stronger the London forces between molecules. Therefore, the higher the energy needed to overcome intermolecular forces of attraction, the higher the boiling point. And this is what you had to write to get the 4 marks. Next, the hydrocarbon C2H6 reacts with bromine Br2 to form C2H5Br under suitable conditions. Complete the table below to show the mechanism for the 3 stages of the reaction of C2H6 with Br2 to form C2H5Br. They tell you the reactant, they tell you the product. Don't have anything different. Okay, so the conditions for the initiation is UV light. You're going to use the UV light to break down your molecule of bromine into 2 bromine radicals. Then for the propagation, one of these bromine radicals is going to form HBr and the C2H5 radical. And this C2H5 radical is going to react with a new molecule of bromine to form C2H5Br and a bromine radical. For the termination, so they already gave you one, the 2 radicals reacting together to form Br2. You needed 2 new ones. So C2H5 radical plus Br radical goes to C2H5Br, and 2 C2H5 radicals would form C4H10. 5 marks. From now on, you need to get those 5 marks all the time. It's always the same. Okay, hard to remember. Once you have it, you have it. Next, propene C3H6 has different bond angles and shape around the carbon atoms. Fact: the base formula of a propene molecule is shown below. I would always recommend for you to draw the dot and cross diagram around the central atom. So this is carbon 1 and this is carbon 2. If you look at carbon 1, it has 4 shared pair of electrons around the central atom. They all repel equally, and 0 lone pair that would repel more. So the shape is a tetrahedral and the bond angle 109.5. For the second carbon, we have 3 bonding regions that repel equally, and 0 lone pair of electrons that would repel more. Therefore, the shape is trigonal planar, and the bond angle is 120 degrees. The explanations are always the same. How many shared pair of electrons, how many bonding regions that repel equally, how many lone pair that repel more, therefore the shape, therefore the bond angle. Always the same. 3 alcohols, A, B, C are structural isomers with the molecular formula C5H12O. A, B, and C take part in combustion. Complete the equation. So you're going to form carbon dioxide and water. And to balance it, make sure you don't forget this oxygen in C5H12O. Start by balancing the carbon, forming 5 CO2, 12 hydrogens, so 6 H2O, and then complete the oxygen by putting 15/2, or 7.5 molecule of O2. Then you had to predict the structure of the alcohol forming this product. So again, the carboxylic acid, you're just going to replace the OOH by a OH. For the ketone number 2, secondary alcohol with the OH on the second carbon. And for C, it has to be a tertiary alcohol. The only way to have a tertiary alcohol is like this. So make sure you have the right number of carbon, and don't forget the OH group. Primary alcohol can be oxidized draw a label diagram to show how we set up the apparatus. Make sure you don't forget the heat. Make sure you put the condenser in the right direction. Make sure you put the receiver, water in and out, and the thermometer. Our second